Good morning students. In the last class we have discussed about maximum and minimum value of function in its domain. Today we will discuss about local maxima, local minima, absolute maximum, absolute minimum values. So first we will understand what is the local maxima or local minima. Okay? So for that we take one example. In your exam you got 70% marks. Okay? But you are not the topper of the class. But in your locality, where do you live? Where you live in your locality, you are the topper one. You got highest marks. So we can say you are local maxima. Okay? Sometime function do not attain maximum or minimum value at some point. But in these points, function can have maximum value in their neighboring points. If you see the graph at this point, okay, highest value, maximum value of this function at this point, okay. But if you see this particular locality, you can say locality means one interval. In this neighboring points, at this point, function has maximum value. Okay. Here at this point, in this neighboring points, at this point we have minimum value. Here also this is minimum value in this neighboring points. Here we have maximum value in the neighborhood of this point. Okay. So these points are points of local maxima, local minima. This 1, 2, 3 are points of local maxima. These are points of local minima. Okay. Clear? Local maxima, local minima. There are some points, okay, at which we are getting maximum or minimum value, but in particular interval only, not in its domain. See, one more thing here. This is local minima. It is local maxima. But value of local minima is more than value of local maxima. Okay? Now you got 70% marks in your locality. So you are the topper one. But in other locality, one is getting 72% marks, but he got least marks in his locality. So he got least, so he is local minima. But if you compare you two, then he is getting more marks. So local minima can be more than local maxima. Okay? So if you define local minima, local maxima, you can define like this. A function is said to be local maxima at x equal to a if f of a is more than f of x for all x in this open interval a minus h comma a plus h, where x should not be a. Or f of x can have local minima at x equal to a if f of a is less than f of x for all x in this open interval. Okay? Here this function has maxima, local maxima at this point. Okay? So what happens here? In this part, here suppose it is a, this point is a. So here it is a minus h. So if you consider a minus h to a, this in this interval, this function is increasing. If we draw a tangent at this point, what happens? Its slope will be positive, more than 0. So here function is increasing, and here from a to a plus h, function will be decreasing. Okay? And at this point a, derivative f dash of a will be 0. So one necessary condition for having maximum or local maximum, f dash m should be 0. Same way for local minima at this point. So if we in this interval, if we draw tangent, it will be, and it will have negative value. Slope of tangent will be negative, and here positive. So this function is decreasing. Okay? So for that, here f dash of a should be 0. So one necessary condition is for my local maxima, local minima, for function at x equal to a, f dash a must be 0. Then only we can get maximum or local minimum value. Okay, but it is not sufficient because sometimes f dash of a is 0. F dash of a is 0, but value of function is not maximum or minimum. Suppose f of x is x cube, है ना? If we differentiate, we get f dash of x equal to 3x square. So at x equal to 0, derivative is 0, but at x equal to 0, we cannot get maximum or minimum value of function. So it is necessary condition that f dash of x should be 0 for maximum, local maximum or local minimum value, but it is not sufficient. Okay? Now absolute. Achha, one more thing. Here, the point at which f dash of x becomes 0, the point at which f dash of x becomes 0, at the values of x at which f dash of x becomes 0, but function do not have maximum value or minimum value, then values of x called stationary points. Okay, the point at which f dash of x becomes 0, but at that point function do not attain maximum or minimum value, then that points are called stationary points. Then f dash of x is 0, f dash of x is 0, or f dash of x does not exist. Okay, the point, the values of x where f dash of x is 0 or f dash of x does not exist, that points are called critical points. The point at which derivative is not 0, derivative is 0, okay, the values of x where derivative becomes 0 or derivative of function does not exist are called critical points. Okay, here values of f dash of x, values of x where f dash of x becomes 0 and function do not have maximum or minimum value are called stationary point, and the point at which derivative does not exist or derivative is 0 are called critical point. Okay, now we'll see absolute maximum or absolute minimum value. So consider this interval a to b, closed interval if you take. So f of x is less than f of c, f of x less than or equal to f of c, okay, where c belongs to this closed interval ab. Okay, so f of x is less than or equal to f of c for all x belongs to this interval ab. Then we say f of c is absolute maximum value. Okay, and if f of x is more than or equal to f of c for all x belongs to closed interval ab again, then f of c is called absolute minimum value. Means in this interval the point at which we get maximum value is called point of maximum, and the value is called absolute maximum value, and the point at which we are getting minimum value, okay, it's called point of minima, and the value is called absolute minimum value. Check. Now to find local maxima or local minima, we have some test, first and second derivative test. So what are the tests we'll see. So first you can note down this.